Okay, good morning, everyone. Welcome to Ippm and welcome to IETF 106. So, since this is the first meeting, here was the note. Please do take the time to look through this and kind of know the what you're getting into by participating here at IETF. If you haven't looked at this before, the blue sheets are going around, so please do sign your name on all of those as well. So we have a pretty full agenda today. So today we will not be necessarily having time to go through any lightning talks at the end. We did have a couple people with lightning talk content, and so you can look at that just on the list of slides that we have. So we will be starting with just some status on the documents that we have in the group, and then we're going to cover some stuff from Greg about the stamp Yang document and the option TLV. After that, we're going to get an update on our registry documents from Al, as well as the route, the ARA document. We're also going to get some time to talk about multi-point altmark and the updates there. And then we're going to have a fairly long chunk to talk about all the work on the various IOAM documents. So these are all the working group documents we're covering. After that, we do have some time allocated to go over other work that is not yet adopted, but has been receiving good discussion on the lists that we are interested in as a group. Do we have any agenda bashing? Any thoughts here? All right. So looking at the status since we met last time, we have adopted 2 new drafts. So we have the IOAM flags document was officially adopted. And then we also did adopt the IPv6 options document, and this is based on the feedback from 6man. The stamp document is in the RFC editor queue. So that's great. Gonna get that shipped. And the metric registry and initial registry documents are currently in ISG waiting on AD write-up. And we did get some feedback there from Ayana about the registry request, and I assume that Al will be going into more detail on the status there. And the other document that we have that's out there is TWAMP Yang still remaining in MISREF, and hopefully that gets cleared up as all of these other documents push through. So that'll be great. I think that's all we have here. So with that, Greg, do you want to come up? Here's the clicker. It's working. It's working so far. Let me know if it doesn't.
Thank you.
All right. Present.
Okay. So the update on the Yang model is that
Is it working?
trying again. No.
Okay. Is that?
Yeah. Okay. We discussed and we had a very good comments from Henrik Nidell from CDN about their resolution for their timestamp, and looking at applications that are in ultra reliable low latency silo of 5G, we agreed that it will be beneficial if their unit would be a nanosecond, not a microsecond. So that's what we have changed. We changed units for their delay and delay variation from microsecond to nanosecond. Okay. Any questions, objections to that?
These are 32-bit nanoseconds? It's a gauge 32.
Yes.
So 32-bit nanoseconds means the max val is 4 seconds.
Yes, that's what we thought. For delay, we made it 64 gauge. I think that we need to go back. Yes, for the delay, it's a 64. so which gives us plenty of delay.
Great.
But for delay variation, yes, you're
Oh, the
correct.
variation. Okay.
Yes.
Okay. Yep. Okay.
Yes, we discussed that and we decided, well, we might get by with the 32 for delay variation.
Yeah. Okay.
But again, because this is a working group document, we made this change and we propose it. So if there are any questions, concerns, please bring it on the list. Next. Okay, no, just a little bit back. So, and for the percentile, we made the change because it was different units. So, but now it's the same nanoseconds because that's what makes sense for the percentile. Another change that we made is their way of expressing the request for the percentile to be reported. It used to have 3 decimals. Actually, no, I'll correct myself. It used to have 2 decimals, which allows you to do 99.99. There was a suggestion, okay, why not to make it bizarre and make it 5 decimals? Because we do have space. So now you can express 5 nines after their decimal point. So if there is any questions, concern, please bring it up and we'll talk about it. But that's for now what is potential to express as a percentile request. Next, please. So the UDP port, we had a discussion in the list about what could be used as a destination UDP port. And the agreement is that one of its 862, which is assigned to TWAMP test protocol. And then it's a user range and a dynamic range. The user range does bring their potential for the using STEM packets as a denial of service attack. But, well, on another hand, we were told is that operators would like to use this tool as a simulate certain applications. So basically, to be to have a higher level of guarantee or chance to follow the same path if you share the destination port address with your application. And usually that probably can be done and used when you're doing a service activation testing. So when there is no active traffic, so you're not piggybacking on your active application. Again, if there are any questions, concern, please bring it up. Next slide, please. Okay, so we still owe a lot of updates and improvements to the text with the reference and everything to address all the comments received as early Yang doctor review. We'll be working on it now more actively once the base specification is out of our hands and being published. And comments are welcome, always. Any questions? Okay, so let's discuss it then on the list. Next, please. Extension draft. Next. No, that's fine. I'm just, yes. So we do have 2 new co-authors. Welcome Eddie and Ernesta. And they contributed 2 new extensions that are access report TLV and follow-up telemetry TLV. Please, next slide. So what is access report TLV? It comes from performance measurement function that is worked by 3GPP, and their intention is, or at least one of the proposals is to use STEM protocol as a performance measurement function in ATSSS. But it does require, or it was considered that it will be convenient if the same protocol, in addition to measuring performance, will be able to do some specific 3GPP pass information in way of announcement. And this is the purpose of access report TOV, which provides the information about access identifier and the return code, which signifies basically working available or not available. That's for now. And access identifier, actually, it's a very simple characterizes the access as whether it's one of the technologies that defined by 3GPP, or then it just identifies as non-3GPP access. And because this is more like even its announcement, but it requires explicit acknowledgement. So once their node sends this packet, STAMP packet with the access report TOV, it arms the timer. And then if timer expires, then it may repeat the report. And there should be a mechanism to control the timer. I think that their default value is set to probably like 3 seconds. And default number of transmissions, consecutive transmission, is 4. But again, that requires control, so that can be changed. Okay, let's go next. Follow-up telemetry TOV. I think that back in OWAMP, TWAMP documents, especially in TWAMP, this document, we discussed that for the reflector, and the same for the sender, to get accurate timestamp is a challenge because the timestamp better to be recorded in the packet as close as possible to the physical transmission of the packet. So to exclude queuing, which introduces delay variation. That's the purpose of this, but that's basically to collect the follow-up telemetry from the reflector. And I can explain why the sender is not critical, because especially in a virtual machine environment, the sender may get their physical timestamp from their hardware once the packet being transmitted. So it can associate this value, even the value in the packet was different. So the sender does know the real transmission timestamp. The problem is more on the reflector side, because the reflector puts the timestamp, and then timestamp is passed for the transmission, and when their hardware passes this timestamp to their reflector application, the packet long gone. So that's the purpose of follow-up telemetry TOV. It may be included in a consecutive stamp packet so that real transmission timestamp for the preceding packet will be returned to the sender. In this way, basically, you can associate, and because it has a sequence number of that preceding packet, so you can associate the real timestamp of a sending packet on the sender with the real timestamp on the reflector and get more accurate measurements.
Hi, Sarah Banks, Corelight. I have a question. Are you proposing then if I set the timestamp in hardware, send it to a reflector, the reflector can't consume, for whatever reason, that timestamp, you're allowing the reflector to overwrite the timestamp with its own timestamp?
No.
Okay.
No. Again, in the packet, in the stamp packet, there we are collecting 3 timestamps. So there's sender transmission time, reflector receive time, and reflector transmission time. This is the follow-up information. So basically, in addition, it's a TOV that follows stamp packet. And it collects specifically only information that the reflector may have from the hardware if we believe that it has access to their more accurate timestamp for the preceding packet. It doesn't override any other information, a timestamp that we normally collect in the stamp packet. It's an additional information. Okay, let's imagine this. The sender sends a packet. It received by the reflector. And then the reflector prepares that reflected packet and sends it back.
Mhm.
So in the packet that it sends back, it has 3 timestamps.
Hmm.
Okay? The next packet from the sender will come with a follow-up telemetry TOV. So the reflector will put all 3 timestamps relevant to that second packet in a stamped packet. And then their timestamp it acquired for the preceding packet, it will put in a follow-up telemetry TOV. So there is no override, there is nothing, no information is overwritten. It's additional information.
Is the confusion about what that extra timestamp is representing? Because it's
Yeah,
the actual transmission time, right?
Well, again, the reflector doesn't know it's actual or not. But if there is a situation that hardware provides or a system provides with a more accurate timestamp on the physical transmission of the packet, and this information, at least in some systems, available to their application that requested the transmission.
But it's not clear to me how an application would make the decision that the reflector's timestamp was more accurate than the sender's.
No,
First.
it's not the senders. All their
Huh?
It's a hardware replacement for.
Uh,
software.
Do you want to come to the mic,
Right.
Al?
Yeah, sorry.
How do you know the sender didn't put a hardware timestamp in the first place?
no, sender doesn't involve here. This information is returned by the reflector.
Yeah, I don't understand.
I don't know.
Al Morton, this seemed to make sense to me, but maybe it deserves more description in the draft, Greg.
Okay, thank you.
Sorry for jumping.
No, absolutely fine. Sorry, Rick Taylor. I understand what you're doing here. I have a couple of quick questions, and it might be my lack of knowledge in STEM.
No.
How does the application that's actually consuming this telemetry know that follow-up TLVs are going to be used for this particular path and perhaps not for that path? And where is the negotiation with the user application?
Okay, that's
Or
good
does a
question.
random fourth TLV, a fourth
Well,
timestamp arrive
again,
and it goes, oh, I forgot about that sequence?
No, okay. Again, the assumption is that this information is returned for really immediately preceding packet.
Understood.
Okay, so true, there is no assurance that packets, even consecutive packets, follow the same path.
Understood again. But if I'm writing an application that's using STAMP, how do I, as the application in my control loop, know that I have to wait for the follow-up telemetry TLV in order to get the accurate timestamp, or just say, hey, I've had my response, I've got my 3 timestamps,
Well,
I can go act.
Okay, good question. Because instantiation of the test session is based on some management, and one of these would be Yang model. So you would know whether you want to use follow-up telemetry and whether your reflector will support follow-up telemetry.
So pre-configuration
Yes.
out of band at
Yes.
both ends.
Yes.
Okay, understood. Thanks.
Mia Kulevin, I have a little bit more a process-related question, and it's more on the previous TLV you added. Because since this document was adopted as a working document, you now just added 2 TLVs to it, right? So like, how much more do you want to add, and how do you, like, why does it have to be in this document? You could also have follow documents that would be discussed separately by the working group, and especially the previous TLV. So there's no work in 3GPP that is adopting STAMP already for any kind of measurements, and I'm not sure how likely that is. So maybe this TLV is not even needed at all. There's no decision made. So maybe that's too like premature to actually add it to the draft.
Okay, point taken. Thank you.
Sorry, Rick Taylor again. Going back to the previous TLV, and I suppose I need to go away and read the draft properly.
Actually, there is a merger reflected. So it's basically, it's very special case for their 3GPP PMF requirements, what they want to do. And decision was that, yes, if we use STAMP as a performance measurement function, then why not, rather than introducing a new mechanism, use existing mechanism to do this state reporting.
Okay, so I'm involved with doing a lot of performance measurement on non-3GPP radio links. So I'm really quite interested in, sorry, I've got a cold. I'm really quite interested in this sort of extension point for non-3GPP radios. So A, I need to get involved, and B, I'm not sure this is cooked yet. I think there's some more that could be done here to make it a bit more powerful. So but I need to understand better what you're trying to achieve with this TLV.
That will be excellent. So let's talk together. Let's bring it to the list, and let's make it. Okay. So yeah, comments are welcome. I think that working group last call, it's a premature.
Yeah, that makes sense. All right, thank you for sharing this.
Mhm.
I think based on this discussion, a couple follow-ups. Since we are adding TLVs here, which I think can certainly be appropriate, but since this is a working group document, we do want to get a good idea that the working group agrees with this in consensus.
Right.
So I think we can maybe have like an email thread of just kind of getting consensus on these TLVs to make sure if there's any concerns about them that can be raised, and we can see if these are appropriate to take. For the access report TLV, I think we've heard feedback that having something that's generic would be good. And to the point of the interaction with 3GPP, it may be easier if we, allow it to be used for other cases, such that if 3GPP doesn't decide to use it, it's still fine. And I think we do want clarification. I read through the text again for the follow-up telemetry, and at least my impression is trying to help you measure the delay between software and hardware transmission on the reflector in a way. It was just like kind of explaining why you would use this, I think would help get to the point, because I think it's useful, but we need to have clarification.
Sorry, very quick question again, underlying my lack of knowledge on STAMP. Is there any kind of in-band extension negotiation within STAMP at all? It's all out-of-band pre-configuration. So from a process perspective, you could move ahead with the raw STAMP, the basic core STAMP document, and then produce later drafts which say, this is extension, have an IANA registry or whatever is required for, you don't need a registry, there's no code points.
Yeah.
So you can split this up from a process perspective.
Okay, thank you.
Thanks. All right. Doing good on time. Okay. Can you give the clicker a try?
Yeah.
Yeah, okay. It works for PDFs.
Ooh, okay. Hi, everybody. I'm Al Morton. And we've been working on big teams, basically have been working on a performance metrics registry and the initial contents of that registry since 2012. Can you believe it? Let's finish it up, okay? and really, we're damn close now. And you can see that right here. The IETF last call is complete, and we only got that after Miria's review. Miria's review was very good. We made a lot of changes, and drafts 11 and 20 of the contents and the registry design itself are the result. Thank you, Miria. So now we have the GenArt and the security reviews, and they really were mostly about helping IANA do its job. And that's good. But we also got an IANA review during last call, and they basically said what the last line is. Their review's complete, but they'll work with the authors to establish and populate the registries. And that meeting happens this week. I've seen Michelle Cotton, she's here. If anybody's interested in joining that meeting with Michelle and me and the rest of the IANA staff to sort out the last details, thank you, Benoit. We'll do that. Ronnie Even, who commented for GenArt, may be willing to do that as well. So the big knockout for understanding this registry and what it is has been a mock-up that we created. And we're trying to get IANA to post that in a temporary place. So we're going to work that out this week too. And here's why. The registry itself is fairly complex. It's got all these categories of summary, metric definition, method of measurement, output, administrative info, comments, blah, blah, blah. IANA is only going to deal with the summary column and have a link to a text file that displays the rest. And here's how that looks in practice. So we start out here, we have the registration procedures. Now, incidentally, that's going to change. When I first met with Michelle about this years ago, she said, please make this expert review. Please make this expert review. Please make this expert review, just like saying Beetlejuice 3 times. And so I heard her, and we made it expert review. But it looks like it's better to make it specification required, because that includes expert review. So now, we're going to make that change. And who are the experts? It's performance metrics experts, and so forth. So this information should really go in the registry design draft as well, not just the mock-up. So it's a performance metrics group. We're going to have a performance metrics registry, and really there's 2 registries included below there, but I think we've actually designed more now. So the summary includes an ID, a name for the metric, the URIs, which we've reduced now just to the URL to the text file that's HTMLized, that brings you all the good stuff, and about building a metric and method of measurement that's compliant. And we have a nice description there that nobody's going to be able to read today at all. My apologies. The change control is an open issue. Michelle told me when we added that it should be IETF. There was a discussion about it, that maybe it might become IESG. I don't know if that discussion has concluded, but we will do the right thing. We'll put the right value in when we're done, okay? So let's just take it as that. We know that the names like RT delay, active, IP, UDP, periodic, blah, 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 that's going to evolve over time as we get more metrics. So we want the metric name elements to be a registry that people choose from as well, extensible registry, just like the metrics. And we will be able to add to those for different things that we measure. Okay. Does anybody in the working group want to raise issues on these 2 drafts now, or forever hold your peace? Thank you, Mirja.
Mia Kulevin, I just noted that it says expert review or maybe specification required in future, and IETF standards action. Is that on purpose, that you only want proposed standards and not informational documents in here?
Well, we do want specifications, I think. We have a fairly high bar for this. It's got to be metrics that are in widespread use, and we don't want to be sort of blasted with metrics that are
Yes, so I think you want
that don't have
you
industry
want-
consensus. Let's put it that way.
You want a specification and expert review if you assign based on a specification, or if you have an RC, you don't need the expert review. Is that what?
Oh, no, you still need expert review, because somebody's going to have to build the metric entry,
Okay.
and the experts are going to review that as well as with the support of the specification.
Because at least on your slides it says IET expert review or standards action.
Right. So that's going to be standards. Well, I guess it's going to be reference required. That's specification required.
Only specification required.
Yeah, that's what we're going to
That's fine.
change it to. Yeah, I didn't update this. Sorry. Yeah. Sorry. Good catch. I have to fix that. Yes, please.
Rick Taylor, very quick question. Are you still reserving some experimental space? These things are hard to do, and we'll need a little bit of random space to build experiments to work out whether what we're doing makes any sense at all before bringing it to the IETF.
Here's what you can do. We already found out when going through working group last call that there was like an experimental, not an experimental, but a private version of this registry being built in Brazil. And that was kind of cool. And they helped us clarify a few things. So I would say, build your metric, test with it, be able to tell us how widespread it is, and and whether the met specification of it works with sufficient.
Al, can I interject a clarifying answer? Can you go to your example registry thing?
Yeah.
Show me the thing with the IDs.
I'm going the wrong way.
Yeah.
Right.
Yeah.
Here we go.
Yeah. Right. So that ID number, that's not a code point that's going to show up on the wire. That is uint infinite length T.
Right.
Right.
Okay.
So like there is the practical limitation that like you probably want your names to be less than 4 kilobytes. So the set of names is like the set of possible 4 kilobyte UTF strings, which I think is large enough that, I mean, there's experimental space because there's no scarce identifier space that we're allocating out of.
Okay, fine.
If someone were to then build a protocol that used this registry and say, I'm going to use the ID, we'd have to talk to them. But like the registry here has like a whole bunch of pointers to this working group. So as long as this working group is here, and it's been here since '83, so I think it's going to be around for a while, then they would come to us and we would say, don't make this a uint8t. But I don't think that needs to be in this doc though, because the doc is not like the level of metrics that we're dealing with in this registry and the transports that we're going to use for those are going to be not such that we really have constrained space. Like it would not make sense to have this ID be a constrained integer space.
Okay, thank you. That I understand.
Yeah, that's
Thanks.
better. Better answer. Much better. Okay.
I thought I understood his question a little bit better than the one you were answering.
Good. Thank you. Cool. No requests for the floor. So I'll send to the list when I schedule something with Michelle Cotton and her staff from IANA. Folks are willing to join us, please do. And let's move this along. This is 2 big drafts that's been around for a long time. It's helping get stuff off our milestones. Thank you.
Thank you. So yeah, you'll send out an update of when you're going to meet with IANA, and then hopefully after that we can get an update of the outcome of that to the list. And then when do we expect probably to have another rev to incorporate that?
It could be this week.
Great. Fantastic.
I'll try to edit while Michelle and I and Benoit are talking.
Do it live.
Yeah. Well,
Great.
Yeah, done.
Okay. All right. So next we have Al.
Yes. Okay. So a couple of years ago, we started on a draft on route metrics. And Carlos Pinataro gave it a cool name, the Advanced Unidirectional Route Assessment, AURA, that just identifying that acronym. So we're at version 5. Last time we had Frank Bachner's review, which helped us change the terminology. Instead of the old RFC 2330 host, we're using node now throughout the document, but we've retained that where it makes sense. That's a quick one there. So that's cool. We've differentiated some of the limitations that we were discussing in section 3.6 about basically they're about trace route style methods and getting back the same IP address from the host. That's not going to be true for hybrid, so we fixed up a lot of items in 3.6 to say that there's differences when you use the hybrid methods. So then the formatting of the results, we decided not to update RFC 5388. We're just going to set out the requirements, punt the future development of that to a Yang model, and the working group agreed. Footer's comments and questions were also about that, resulted in adding another requirement for the future model, the original sender's timestamp. So we got a list of requirements now in section 3.6. So then we said in IETF 105 back in Montreal, we said we'd like to see a working group last call at IETF 106, started here at least. And now with the resolution of those comments and the new drafts, we think we're ready for that. And that would help us move what we believe is a very mature draft on its way. And so working group last call, please.
Could we
Any
just
comments?
see a show of hands of how many people have read the recent version of this document? 3.6?
Hey, Carlos, put up your hand.
4 or 5? All right. Yeah, sounds good. So, I mean, please do take a look at this, and I think if we do we can get a last call going for that probably. Sure. I mean, we will send out an email. Do you want to send out an email?
Go ahead and I'll click the button. Yeah. 3 weeks.
Yeah, give it 3 weeks. And yeah, please do read through this and raise any issues you see. But yeah, it would be great to get this moving along.
Cool.
Thank you.
Thanks, everybody. I think I saved you some minutes.
You did. So Giuseppe, coming up. And like this was, so we wedged this onto the agenda at the last minute and at great expense because we just completely forgot about you. I'm sorry. We gave you 5 minutes. We're actually running a little bit ahead, so you can use a little bit more than 5.
Okay, if needed.
Yeah.
Particular for comments.
Yeah. Clicker.
Okay, good morning. This is an update of our multi-point alternate marking draft. Just a summary about the idea. We want to introduce this intelligent OM approach. So we started, you may recall, from RFC 8321 that allowed unicast point-to-point flows performance monitoring. And we moved to this multi-point alternate marking approach that allowed the monitor of general multi-point anycast flows without any constraints. So what is the motivation? The main motivation, it is resource consuming to monitor all the flows and all the paths continuously. So we should figure out a way to make this in a flexible way. The solution is to put intelligence into the system. So to give the intelligence to the controller to be able to manage the performance measurements. And for example, it can start without examining in depth the network and then go deep if the problem have to be analyzed in some position. So there are 2 ways to act. If we go to the implementations, the first way is, of course, to specify the traffic filters to find more detailed flows to be monitored. Or the second way, of course, is to activate new measurement points. And how we activate 2 new measurement points? By using the clustering and the network clusters partition. So network cluster partitions allow the division of our network graph into clusters that are the smallest subnetworks that we can identify. And this cluster can be also combined in different way to activate, of course, new measurement points. The change that we did from the 0.2 version was, in particular, we added the reference. I remember the comment from José Ignacio, and we added the reference to a new paper that is about the definition and mathematical formalization of the algorithm for cluster partition, so that it can be applied for every kind of graph. And you can download this paper, but also I became aware that it was published, so you can also find on IEEE Explorer by yourself. Anyway, it's also available on this website. Just a look again at the algorithm. So this is the iterative approach. We can, if we have a network graph, the first step is to group the links with the same starting node. So for example, in this network graph in the figure, we can identify 5 groups with the same starting node. And then in the second step, we can join the group with at least one ending on node in common. So in this case, for example, the group number 2 and group number 3 will be joined to be the cluster 2. So in general, for this network graph, we can identify 4 clusters. This is just to give you a view. In this case, it's very simple, but you can imagine that if you have a network graph more complex, we can make this at a different level, and we can also combine the different clusters at different level to activate more measurement points. Just a recap on what kind of measurement we can do. So this is a complete performance measurement framework. So we can measure the packet loss on multi-point path basis, or we can do that for single flows or for the whole network. So this gives you the flexibility to measure packet loss at different levels, as I said. And in addition, of course, the delay measurements that in same way can be done at different levels. So we can measure the delay on multi-point path basis. That this means that the delay has the meaning and is a representative of the multi-point path. Or we can do this in a traditional way on single packet basis. In this way, we should ask the help of an older FSC, that is the 5475, about the hashing selection, because the double marking methodology of the RFSC 8321 does not work for multi-point path. So we should use the hashing approach to couple the samples. But in this case, it will be simplified because we can use the clusters to couple our samples in terms of space. And we use, of course, the marking method to couple the samples in terms of time. So in this case, the coupling of our samples is very simple. Okay, the next step. So the document is stable, and the authors suggest to begin the path to become RFC. If you have additional inputs, comments, of course, are welcome.
So again, I'd like to see a show of hands on this one. Who's read and reviewed this document? 1, 2, 3, 4, 5. Okay, good. So by beginning the path to become an RFC, is that a sidelong request for a working group last call, or? Yeah. I think we've seen. Well, let me actually have a look. So many data tracker tabs open. All right. It was November 4th, right? We're on 03. Yeah. Do we want to go ahead and start a last call on this one? We can do that too. We can pipeline it. Yeah. Okay. So we will. Well, we've had bad, like we've done a couple of times where it's like, yeah, we have a working group last call. Let's start another working group last call after that first working group last call, and then we forget about it because like this working group last call just started for to end on December 9th. So then we do one on December 9th that ends at Christmas. Are we going to do that? Are we going to remember to do that? I was just saying our track record here is not great. Okay, cool. So, okay, Tommy is putting a reminder in his phone that we're going to start a working group last call on this one once the working group last call on Aura is done, which will be December 9th.
Okay.
And then we'll click the buttons and make that happen, and then that will probably end, like a couple of days before Christmas. So,
okay.
And then we'll definitely have it done.
Christmas present.
Yeah, exactly. There you go.
Okay.
Cool. All right. Thank you very much.
Thank you.
So next up, we got Frank. Oh, you're okay. I was looking for you earlier. You're hiding back there.
We have loads of time,
We
right?
have loads of time. Get 25 minutes.
We're running early. Cool.
We're running early.
All right. So, quick update on.
Clicker.
Ah,
we're
we
running
even have a
super
clicker. So, quick update on the 3 working group adopted IOM drafts. So, not the whole kind of enchilada. So, the oldest and I think most well-discussed document is the data draft, as we typically refer to it. So, the data draft has seen 2 updates since the last meeting, and I'm going through them sequentially. So the first one is addressing, or the 06 to 07 update basically addressed, well, a detailed review from Hayu and another detailed review from Tom with the additional feedback folded in from the hackathon that we've done at 105. And so there's 2 types of main updates that we received from there. So the first, and that's, I think, the technical real update, was a rearrangement of the flags field that we have for the various data fields in IOM. And so the starting point of that rearrangement was that out of the hackathon came the suggestion saying, well, you have 24 bits for the various data fields, what if we ever run out of that? So we need to go and at least have one field or one bit dedicated to future extensibility. So let's reserve one of that. If you reserve one of those, well, make it the last bit in the field. Oh, the last bit was taken. So 23 was already taken. So we wanted 23. That means like from there you kick off another range of additional changes that roll into that. So we made room for that. And then the additional thing was, if you look at how IUM data fields are structured right now, we have two types of data fields. We started off the initial journey with always fixed format data fields with a defined syntax. So all the fields like node ID, interface identifiers, timestamps, and the likes, they all have fixed format, which is good for a hardware implementation. But later on, I think people said, well, I want this and this and that. I want flexibility. So we also have TLV style formats, which is what we call the opaque opaque snapshot field. A little bit of a funny name for a TLV formatted content there. And the argument out of the hackathon was like, don't really give me a field structure if I need to go and implement that I have something fixed format, then I have something flexible format, followed by something fixed format again. So not a great idea. So it's much better to have something fixed format and then, well, have the flexibility later on so that from a parsing perspective, things become more simple. That meant, okay, you want to go and have the opaque snapshot field after all the fixed fields. That means opaque opaque, oh, I hate that word. Opaque state snapshot, especially at 3 a.m. in the morning, right? My time. It is now bit 22, so that everything is fixed prior, and then you have opaque state snapshot. I'm getting better at it. And then you have, well, anything future that we don't really know about. So bit 22 was taken. And then, well, we kind of moved the other stuff around to go and not end up with any holes in the current allocation. So that's the bits rearrangement that we've done as part of 07. The other thing that really changed is, and that's what Hayo drove, is when we started writing the document, if you looked at the recent version of the document, it became very apparent that the document had a shitload of different authors. And given that we did this kind of really GitHub style, so everybody implemented something, and then we ended up with things like, sometimes it was referred to as IUM type, sometimes it was called the IUM header, sometimes it was called IUM option. But basically, we all refer to the very same thing. And now the very same thing is called the IUM option type. Again, not a beautiful word, but a kind of, it's a perfect compromise. Everybody is equally unhappy about the compromise.
Why not the IOM option type header? Header option type.
Go and create a pull request. We're happy to pull it in. But make sure that you're catching all of them. So I tried really hard to go and catch all of them. And yeah, so that cleanup happened along with, so we had certain things that were really given a dedicated section, like nomenclature for the namespace section, but other things didn't really have a dedicated section in section 4 or a subsection. That again got cleaned up, so I hope that I kind of made the overall thing more digestible, cleaner, with the same level of kind of nomenclature throughout the document, so that we are really ready towards, well, ultimately working group last call. Then I pushed that 07 out on the mailing list, and well, what typically happens is there's something else that you forgot about, and that was issue 135, where one little thing that we forgot about to specify was is what happens on decap if, well, what should node do on decap? And well, we believe that it should go and get rid of all option types, no matter what, for a particular namespace that it's kind of responsible for. And that was also not said in the draft. So again, a little bit of additional cleanup that is in there. And so sent to the mailing list, no comments received. But well, as usually, there's one more comment. You can not do that unless we're an IETF. And we brought up the question earlier on. So I think at 8:30, Tal was friendly enough to go and schedule a breakout meeting or a site meeting like it's called here, and bring up the question again, is there any comments on the data draft? And guess what? There was one, and Greg had one. And he posed the question, and I want to go and reflect it back to the room. It goes back to the earlier thing about what data fields we have. Today, we have data fields that are fixed format, and then we have this kind of catch-all TLV style for everybody else. Now, if we look at the fixed format data fields, there is a little bit of flexibility into the fixed, built into the fixed data fields, because we have short and long format of 4 different types of fields: node ID, interface identifiers, timestamp, and namespace-specific data. And well, these fields can be kind of combined even, right? So you can have short plus wide, making super wide. So that was us to give us fixed format fields with a little bit of additional flexibility, so that people who are really constrained on space, and I know that several people are, because they say, well, I'm ready to go and record 60 bytes. I have a diameter of, say, 5 hops in my network, and how much information can I really fit in? So people believe that there is use. But the question that Greg, and I think for a really good reason, raised is, do we need this kind of interim flexibility? Shouldn't we really have something that is really small and fixed? And then if you want to go a little wider, you end up in the TLV land. Or do we want what we have right now, which is small and fixed, a little larger and fixed? And, well, if you want to go crazy, you go crazy with TLVs and make your hardware bleed. So I think the question to the room is, do we want to go with what we have? And if we want to go with what we have, I think we can go and consider really being ready for, finally, after 15 iterations of the document, 7 as personal draft and another 8 as working group document, that we're able to progress to working group last call, or kind of how do you want to go and deal about the question that was brought up in the earlier breakout, site meeting.
Right. It doesn't matter what you call it. You can call it an option type header.
Option type header.
So, me from the chair. It looks like we've sort of like accidentally adopted a model of pipelining working group last calls, which I actually kind of like. So then we're basically saying, okay, well, we're gonna be doing a working group last call continually at this point, probably till the next meeting. Can we sign you up for the 3rd slot, which would be a working group last call beginning on the 6th of January and ending on the 20th of January? So this gives you time between now and Christmas to make the changes. We wouldn't start the working group last call.
Maybe we don't even need a change, so maybe you can go and at least get a sense in the room for whether
Right.
we need more changes. Otherwise, I'm sold.
Yeah. Does anyone here think that we will not be ready to start a working group last call in January on this one? Like I as somebody who's looked at the document and watched it progress, we're now sort of seeing, the scope of what we're fixing narrowing, and it's like we've done the editorial changes, and it's like it's looking kind of done.
And everything
from
that
where
is
I
kind
sit.
of contentious was moved out, right?
Right. Yes.
And so, yeah, we should have a stable base. And I think
Yes.
it's really beneficial for everything that we do to have a stable base, so that we can go and get the stable base progress to working group last call, and then we can go and deal with the edges, right?
Yes.
So one question I do have about the stability. So it definitely seems to be getting more stable. We did, from the last hackathon at IETF 105, get good input
That's it.
Can you give an update on the status of essentially those implementations that did hackathon work? Have they updated to the new stuff? Do we have do we have confirmation that the changes seem to be good and they seem to be working? It'd just be good to do that also potentially before.
Do we have people in the room
who've done the hackathon before?
who have been at the last hackathon? Is Justin here?
Okay.
I don't see him though. Okay. Ah, there. Now, did you include the 07 changes in the IOM implementation for the kernel? Not yet.
Okay.
That's not yet in.
All right. Would that be possible to play with before January? Yeah. Okay. Great.
And see whether it's breaking anything, right? So that'll be helpful.
Yeah. Okay. So it'd be appreciated to set an update to the group on that.
So yeah, we will then start a working group last call on this first thing next year, so 6th of January. Obviously, if you have issues, you don't have to wait for the working group last call before then. It would be neat if the working group last call is just everybody saying thumbs up. So between now and then, read the draft, figure out if there's anything that needs to be fixed. I would say let's presume that if there is going to be a new rev of this, that we just bang that out on so the 6th is a holiday in Germany, so bang that out before Christmas.
It's not a holiday in
That's
Germany. It's only a holiday in Bavaria.
Oh, right.
There's a difference between these.
Sorry, I'm in Switzerland.
Commonly forgotten about,
Yeah,
but yeah.
Right. So I'm in Switzerland, so Germany is just Bavaria, right? It's that's the.
Oh boy. Oh boy.
Yeah, let's take the politics out of the IETF. Yeah. So let's.
And
let's make
Bavaria
that
is
the plan.
northern Germany for you, right?
Right. Yeah, of course.
Okay,
Well,
got
it's the closest bit. So let's say if there is a rev that comes out of discussion, let's sort of try to get that done in December so that on January we can just hit the button, and everybody says yay, thumbs up, and then it's done on the 20th, and then we can try our luck with the ISG.
Before we do this, right? So could I get a sense in the room, maybe a voice or two, or maybe we can even do a hum, whether people feel like we want to stay with the current format of what we have from a fixed fields.
Right. Oh, that, yeah.
So this wide and short, do we want to go and keep it, or do you want to go and not have wide format? I think that was the thing that kind of bubbled up in the earlier site meeting. I think any comment anyway would be greatly appreciated, because, well, if we have, say, some sense in the room that people say, well, let's go ahead with what we have, it's at least some indication, right? We need to go and confirm that on the list, and I'm going to go bring it up, but any opinions?
Are there people in the room with silicon other than you? That would be right? Because this is So,
Barack, do you have an opinion?
Yeah. Let us get right, because this is you like it.
Just I think there's people online that want to go and they can't see you. They also can't hear you. Now they can see and hear you.
Barack, yeah, I'm for it because 16 bits may not be enough for many cases.
So you want to stay with what we have?
Yeah. Although for other cases where you don't need too much telemetry, they may be enough. So.
Okay.
When you say with what we have, it's what's here in this 06
Yeah.
to 07.
What's in 08 is good enough. Yeah.
Yeah.
Okay.
Okay.
Any other opinions?
Just and also to clarify, so the options that were discussed is essentially sticking with what we have or going to just the short fixed.
Correct.
TLP.
So some people.
No one ever talked about
So-
just doing long fixed.
No, the suggestion is to go and, well, we had that as well.
Okay.
But kind of that was we got rid of that in the site meeting already.
Okay.
So some people said
That's good to
let's
know.
use the lowest common denominator, which means the lowest common denominator would be 48 bits for for node ID and then 64 for interface IDs and whatever. So that means like
You only get
packets quite large. And I think that was like for all kinds of reasons not considered. So I think the option is to go and drop anything white format, which I believe is fairly constraining.
So this seems, I mean, you know, as someone without a dog in this fight, this seems like a perfectly reasonable compromise, right? Like, so this is, let's definitely confirm this on the list, but I think most of the people who have an opinion here are in the room or were in the room at the side meeting.
Yeah.
So, I mean, this seems, I would be surprised if this comes back up. So
It
please
was
don't-
there for a reason, right?
Yes.
It was put in for a reason.
Yeah.
It is there for roughly 3 years for a reason.
Yeah.
But yeah, well, some people always have a different opinion, and I think it's worthwhile to confirm that we're still of the same opinion
Yes.
now that we're 3 years further.
This sounds
down the
like an
line.
opinion to me, right? And I would say, yes, this would be surprising to me. Please don't surprise your chair. So
Yep.
if,
Okay.
yeah, this is, the working group last call is where it is because we want to focus the working group's attention on
Mhm.
one document at a time to get these things out. But please do, speak up as soon as possible, because the idea is that like either what we have right now or a tiny revision will be what we do working group last call on based on, discussion between now and the end of December.
Okay.
Cool.
All right.
Thank you very much.
So next one. Flags. So that's actually a draft that Tel wrote for all of us because it was text that was originally in the data draft, was seemingly contentious, and well, following the strategy that, well, we just discussed, like create ourselves a stable base, let's move everything that is like, not entirely sure into dedicated document. That's one of the examples, and well, the direct export thing is later on another example where we kind of moved things away from the core. So since we discussed last time, we working group adopted the flags draft, which is reasonable because it was in an adapted working group adopted document already, and it even went through additional revisions now that we had 3 flags in there. One was called active, one was called loopback, and the third one was called immediate export. Given that immediate export had another raft of discussions, and well, it has its own dedicated document now, we removed even that one out of there. So that means by now it's only 2 flags in there, loopback and the active. And we had a bit of discussions last time, like, well, what does that mean, these flags? Because they drive a set of behavior, and maybe you don't want that set of behavior for all the packets because, well, it could go and cause harm if it's really for all the packets. So we clarified and specified that, well, absolutely, you want to go and put constraints in so that you only do this for packets that you really want it on. In the site meeting, and let's make sure, given that my brain is not entirely working, I'm able to read, I'm not really able to remember. So that site meeting today revealed another set of things that we definitely want to go and add to the draft. On loopback, and there's that documentation is already in issue 138, and Barak created 138 for that. So the first thing is, with loopback, you're recording on the way, and you're also recording on the way back. Nobody knows why we're recording on the way back. And we couldn't really go and find a good use case for that. So we're going to go, and I think the suggestion from the site meeting is don't record on the way back. The second thing is loopback only makes sense if the sender is also the encapsulating node, because otherwise it's a little funny, because loopback is a probing mechanism. It's kind of a fast traceroute mechanism. That's what it's built for. And so sender needs to be encap node. We need to go and explicitly state that. And in addition, well, loopback only makes sense because you have a node that is supposed to go and send traffic back to the source if there is indeed a source address in the packet. So again, we want to go and specify that it's only making sense for encapsulations where the source is indeed part of the encapsulation or the packet per se. And in addition to that, well, we want to go and have a statement in encapsulation drafts on how loopback would actually be used for a particular encapsulation. I think that, again, makes perfect sense. And in addition to that, we want to have a statement that, well, if an edge node, so an IOM decapsulating node, receives a loopback packet that it hasn't originated, it should go and drop it. Again, I think from a security perspective, makes perfect sense. It should not happen. If it happens, go get rid of it. So that was really the discussion on loopback, refining what we already have in the draft, which is why I think these site meetings are super useful, because you get far more active discussion rather than in the big room. So things are more entertaining, even if it's really early mornings. So that is something that we want to go and refine on the loopback option in flags. The other thing that we have, as I said, the second flag is active. Active didn't really have that much of a discussion, but there is one thing that, again, Greg Mirsky brought up as, well, a bit of a clarification. And his question, and I think his question is worthwhile. He said, well, there is active OEM protocols. There's many of them. You can add IOM information to an active OEM protocol. Check. Right, so you could run BFD and you can add IOM to BFD. Why not? What is the purpose and why do we need the active flag in addition to adding the IOM information? And well, the active flag was put in to basically help implementers and help hardware, to go and tell them, like, with a single bit, you need to go and look at that. You need to look at that deeper. And so that particular behavior wasn't entirely clear from the text that we have. So we're going to go and add a paragraph that says, well, the active thing is really to help implementers, and here's why. And so the likes of Parag are going to go and help specify further why this is needed in order to clarify the use of this. You could call it a helper bit for implementers. So that's, I think, the discussion that we had on the active bit in the flags draft. And that's pretty much it. Did I forget anything, Tel? I think you took detailed notes in the meeting today. Okay, cool. So that's it on the flags draft. If we're mature with that, could we go and consider, like, want to hear anything else about this whole thing? The original idea was to go and keep it in lockstep with the data draft, because these two were good friends. Question is, should we go and do this pretty much at the same timeline? I would love to, because these guys go hand in hand. Well, but only if we are really kind of stable. Mirja.
So I'm still a little bit worried about the loopback flag, because you designed a really nice protocol for an amplification attack here, right? And that's usually what we try to avoid. Which is not.
Sorry, what are we trying to do?
You designed a really nice protocol that makes it possible to have an amplification attack very easy on your network.
No, well, wait, I think actually that the flags draft is the reflection attack. The direct export is the amplification attack. Right, because it's direct. So loopback is
Every
just means
node on the path will send a message back, right? You send one
oh
message.
right, yeah.
Every
Okay, yeah,
node
you're
on
right.
path generates a
This is the
message.
amplification attack, right? Yeah.
Yes.
True. Sorry,
Yes.
confused.
And and like the only countermeasure you have in the draft is you should, like, each device should limit the number of packets they can send, but that's like on a per device basis. But then if you have a pass, you have a number of hops, and it's still not great. I think this is just, like, not acceptable. I think you need to do better than that. You need some kind of, access control. You have to make sure that not everybody just can flood your network just sending one packet. I think you need to do more work here if you want to get it through the whole process.
So do you have an idea?
I mean, yeah, the idea is
So you
just
have a
trace-
problem but no solution. That's what we're saying.
No,
Okay.
I have many solutions, but they might not fill your requirements. I mean, like one is use traceroute because that is not an amplification attack. It's
Yeah,
like one
traceroute is
packet
shit
and you
slow,
get
that's the
one packet
problem.
back, right?
We're trying to solve that trace.
Traceroute is slow for a reason.
Yeah,
If
I
I
know.
may comment, then traceroute has even more packets going in the network than this technique.
Yeah, it has more packets, but it has the same number of packets going in than out.
Right.
That's the important part.
So the fact that a single input packet can only result in a single output packet of a generally smaller size is we have come in the transport area to understand that this is a core requirement for networking at that layer if you want to not kill yourself. I would suggest that you set up IOM flags loop back on a routing loop in a hackathon. And then this is like instructive, right? Like, so if you can create a routing loop with a loopback flag, you have now melted your network. Like, and I think that's not like set it up and watch it burn. Just it's educational. It's fun, right? Like the lights, they come on and then they stay on forever, and then probably a device reboots.
Yeah, I mean, but I mean, whatever you do here, it's more heavyweight, right? So the other option would be to have some more access control so that you actually can identify the device that has sent a loopback request and only reply if you know that this is a device that is actually supposed to do that. So you have to add more information to your packet.
So from a strategy standpoint, the question is, do we want to hold up flags in IPPM while we try to make it safe? Or do we want to send the two documents up to the IESG and IOM data goes through and flags gets killed, right? Like, so like in the state that it's in right now, it's not going to pass sector review.
Okay. But by
And
the way,
actually-
we have other packet replicators, right?
Right.
So
Yes, but we shouldn't make any new ones.
Okay.
Right. So that is actually another thing that we could do is you could take, if you believe the document is ready, then I would say we should request an early sector review. And we will see what sector says.
okay.
And
You know what the answer
yeah,
will be.
we know what we know.
I
What,
think if-
no. Wait, no. We know what one of the answers will be. We in this room have identified the amplification and reflection attack. There may be other attacks, right? So it might be, well, yeah, but if you give it to sector, they're going to find the first hole and then they're going to say no. They're not actually going to dig on it. So we should do something about the amplification reflection attack before we send it to sector.
Good point. Let's do that, right? So I think this is why we brought it up. And so if you have an idea on how we could go and deal with that by constraining access, I'm still not sure how to do that. I have an idea on how to solve the loopback thing, the routing loop problem. We have solved that.
Barak, so I think the routing loop problem that you talk about is indeed severe, but it's not infinite because you do have TTL. And when we restrict the loopback to collect data backwards, then it kind of solves the problem. So I think it's important to solve it, but it's not infinite.
No, but I think it's important to solve it. I think that's the thing. Let's first solve it before we consider any further
Just
steps. in
because
progressing
sending
it.
a single packet will not melt the entire internet forever does not mean that the problem is not.
But keep in mind that there are operations in the network today that are doing pretty much the same. Such
Let's
as
not make more.
That is not an acceptable retort to this.
Yeah, so
right?
just
Yeah.
just
It's like,
because
yes,
badness
just-
exists, you don't want to go and
Right.
pile on it, right? Yeah, it's okay. Good.
Yeah.
Perfect.
We have enough. We have. It's either we have enough foot guns, so foot guns are okay, or we have enough foot guns. Let's not make more, right? Like, and I'm leaning toward the second one. So yeah, I think the next step here is between now and Vancouver. We go off and think about this for flags, and we
Yeah.
basically have a session in Vancouver that is let us come to conclusion on the solution for this problem.
Let's first see whether we can go and converge over email until
Yeah,
Vancouver,
yeah.
and so that we have this significantly better.
Yes.
Because I think also we need to have this other feedback
Mhm.
in, and then we can see whether we can go and come up with something that at least solves the packet replication.
And when we talk about the process for this, because we had essentially agreed for the other one that we could kick off working group last call, I think if you wanted this to be aligned, you would have to delay both of them. So do the authors prefer to do the data last call separately from flags?
I think I have a personal preference. Everybody else can go and speak up. But I do think we decoupled the thing for a reason.
Yes, we did.
And we decoupled the thing in order to have a stable base.
Yep.
And everything else can then progress at the speed that it can go and progress at.
Yep.
So,
Let's stick with that strategy.
well, let's not put all the eggs back into the one basket, given that we have started to go and distribute them.
All right, so I have Mickey in queue. I'm going to go ahead and beam him in.
Hello, can you hear me now?
We can.
We can hear you.
Okay, so I guess a couple of things. So one is I wonder why every node needs to send back. So we do have node IDs in the trace information. It's not an IP address, but it's something. And then the other is there has been some interest in having IOM info go back to the source for closed loop control or other purposes back to NICs. And that overlaps a little with what we're talking about with loopback, and I think it's worth discussing that afterwards.
Yeah, makes sense.
Barak, I agree with that we should further discuss your second comment, but the first comment has to do with the whole intention of it. So if you want to see whether a packet can actually traverse the whole network, then if you will just collect it and then drop the packet, you will not see it. So it's the same thing that as you have for traceroute, if it makes sense.
Some implementations may be able to turn it around if they think they're dropping, but yeah, that's a
So this is one of the implementations, and you don't rely on the implementation of network devices in the middle.
Okay, we can discuss that further.
Cool. All right. Thanks.
Okay, one more. So that's the V6 options draft, which is basically asking for allocation of two V6 options. Again, it was a draft that used to be an individual draft from the IOM team, which is why it's IOM and et al. Originally. From a names perspective, has been working group adopted. There's been nothing really new in this draft other than the working group adoption thing. And, well, a little bit of informational reference to the deployment draft and what have you. And we basically asked for this draft to be adopted to go and follow, what's the RFC number? 7120 something, to go and ask for early adoption of IPv6 option types so that the VPP implementation and the kernel implementation can start to use IANA allocated option types instead of their own ones. And well, they're already diverging today, these implementations. Helps other people as well to go and use the same numbers, even if it's early. So I think that was one of the main reasons why we kind of pushed for working group adoption. I already sent an email to the chairs to kick off that process.
Is that a thing that we have to do that?
Yeah, you have to do that.
Oh, okay, then we'll do that.
According to RFC 71 something. Right, I refer to that in that email. Yeah. Yeah, so it would be good to go and get additional reviews. End of the day, I think it's asking for 2 code points, the draft. All the considerations are in the deployment draft. That goes hand in hand with the V6 draft for now. So the draft itself is very simple.
Xiaomi ZT, I have a question on this draft. When I read this draft, I found it seems there's a alignment issue between this draft and IOM data. Because in section 3 of this draft, it says, unless a particular interface is explicitly enabled for IOM, a router must drop packets which contain extension header carrying IOM data fields. But in IOM data, it says if not all nodes within a domain are IOM capable, IOM tracing information will only be collected on those nodes which are IOM capable. So it seems
Did you catch that one?
yeah, not alignment.
No, I didn't. Sorry, we're looking at 7120.
I think I didn't entirely catch it. So could you
in
go
this
and
job,
summarize what the what the discrepancy is that you believe is there?
In this chapter, it says if this node is not IOM capable, it should drop any packets received with
Drop the
IOM
packet or does it drop the
data.
option?
Data
Does it drop the packet or does it drop the option?
packet.
Oh, yeah, it shouldn't drop the packet. If that's really what it says, then that's odd and wrong. Right. So like, could you go and drop an email to the mailing list with that particular thing? We need to go definitely fix that.
Of course, I can do it.
So thanks for catching that.
That's not a discrepancy. That's just a bug.
That's just like, yeah, well, it's wrong.
Yeah.
Period. Thanks for catching.
Thank you very
that.
much.
Thank you.
We can even get a ref out real quick.
Oh, it does. Oh, yeah. A router must drop.
Oh,
packets.
shit.
Yeah. Oh, yeah.
So
Yeah, that's
that
absolutely
fixes the
wrong. Thank you
replication
very
problem,
much.
by the way.
Hey, It's like the opposite of security is not.
Okay, so
availability. Yeah.
more reviews is really good. It's really good.
Yeah.
Thank you.
Thank you very much. So yeah,
That's it.
we will sit down and figure out we'll go read 7120. We're going to have a look at the process. I think the process is that we need to do a call for consensus about this on the working group
Okay.
list. And then we need to we need to determine consensus, right? Like we can determine consensus by fiat, but that's not really how we do things here. And then we need to go ask Miria and then she'll say no. Hi, Miria.
Yeah, I think I have to be somehow involved in the process,
Yes,
but
you
I
do.
also have to look it up.
Right.
But there are also a bunch of experimental values that you can just use, right?
We can, so the overall
which-
thing why we started doing this was that the two implementations that we're knowing in open source already use different code points.
Do they use
And it
some
would
of-
be nice if the two had some suggestion of what to use.
Do
Right.
they use a random code point or one of the
Mhm.
experimental code points?
Mhm.
Okay.
No, they've chosen something for.
Yeah, so you should go to the people and shout at them and say, like, this is not how to
They're
do
in
it.
the room. Just turn
This
around.
is not how to do it. Use an experimental. The other thing would be, because this is a really short draft, right? It would be just like to bring it through the process very quickly and then have like the final allocation in sometime soon, hopefully.
We're hoping for. We need to go and fix this one.
Well,
Yeah,
For sure.
but that's easy.
That's-
It's like replacing one word, right?
That's actually a good question. Which do we think will take longer? The chairs figuring out how 7120 works or doing an accelerated last
Given
call?
that the chairs are very experienced with that process, I would assume that
I've never done a 7120.
Okay.
but, like it starts with a 7. That's newfangled. I don't know.
up to you,
I don't
right?
understand this. It's
So
modern.
we can go and try either
So
way.
the reason that I would say we should do two reasons why I would say we should try the early allocation thing instead. Number one, it's a new shiny thing that I've never done in the IETF, and it would be fun to try. The actual reason is that it's a little bit weird to last call this document before we last called data.
Check. Agreed.
So let's do the early allocation
Yeah.
thing. Okay. Do you have does our esteemed area director? It'll be fun. You get to click buttons.
Okay.
We should get buttons added.
All right. So that means we can go and dovetail with
Yeah.
the thing that we haven't really discussed, which was immediate export,
Great.
which ended up now in the design team output.
Hold
Of
on, we
direct
have
export.
we have like 1 minute, and I actually would like to take this time from the chair to start the consensus determination process. Is there anyone in this room who believes that an early allocation for these code points so that we can stop squatting on weird bits of the option number space is a bad idea? If there's dissent in this room about doing that, I'd like to hear it. Because we're going to start it. We're going to do a quick call on the list. Quick call is probably going to be 3 weeks because we, want people to actually read it and understand it. To early allocate code points. Is there anyone here who thinks that's a bad idea? Please stand up now. Okay, that's signal. So yeah, we'll go ahead and get that started. Cool. Yeah. Run the meeting and I'll go.
Thank you.
Okie dokie. Thank you so much. All right, so that concludes our section of working group adopted documents. Now we're going to get into the related documents, such as the one we've been discussing, the direct export flag.
Thanks. My name is Tal Mizrahi, and this draft about direct exporting is a new draft, but it's actually not a new idea. It's the product of a design team, which consists of the people listed here. A little bit of history. So this concept was actually discussed in the working group a couple of times, and it's based on two different proposals. One is called postcard-based telemetry, and specifically we're talking about PBTI, which is one of the flavors. And there was also a second proposal, which is called the immediate exporting flag, which was first introduced in the data draft. And then when we split it into a data draft and a flags draft, the immediate export flag was part of the flag draft. So in IETF 105, we had quite a bit of discussion about these two proposals, and the working group chairs instructed us, the authors, to work on this together and to come up with a single solution. And this is what we did. So first of all, I want to thank all the people who took part here and worked on this combined solution. It wasn't trivial, but I think we came up with something that makes sense. So last month in October, we introduced the first version of this draft, which combines the two concepts. So what is direct exporting? So if we look at the figure here, from the left side, we see a data packet that goes into the IOM domain. And when it reaches the encapsulating node can incorporate a direct exporting, a DEX option into the data packet. Then when the packet is forwarded along the path, the transit nodes just forward the data packet. They don't modify it. Finally, when the packet reaches the decapsulating node, the DEX option can be removed. So each of these nodes along the path can also export information to a collector, but the transit nodes don't need to change the DEX option. So that's the main difference here compared to what we saw in a conventional IOM. So the question that comes up here is why is this needed? So the main motivation to use direct exporting is, first of all, since transit nodes don't need to modify the packets, it makes processing by transit nodes easier, simpler. So that's one thing. And another major advantage is that since we're adding a constant overhead, it's a relatively small overhead. So compared to the conventional IOM, which adds per hop overhead, it's a significantly easier or less overhead for each data packet. So there's potential improvement in terms of the data plane bandwidth. So these are the main advantages of using the DEX option. So this is the DEX option format. We can see the different fields here. Some of the fields are similar to some of the fields in the IOM incremental and pre-allocated trace options. So for example, we have the namespace ID, the same as we have in the trace options. The IOM trace type has exactly the same semantics as in the IOM trace options. And we also have two optional fields here, flow ID and sequence ID. Let's see an example. And in this example, we see a DEX option, which is encapsulated in an IPv6 extension header, which is based on the draft we saw a couple of minutes ago, the IOM IPv6 options draft. So as we can see here, we can see the last four words, which are exactly the same as we saw on the previous slide. We see the first word here, which is option type and length, which are the beginning of the IPv6 extension header. One thing to notice here is on the right side at the top, we see the IOM type. This is the indication that this is a DEX option. So we're allocating a specific IOM type to indicate that this is a DEX option. The other thing to notice here is the option data length field indicates the length of this option. So like we said, it's a constant sized option, but this length indicates whether the option includes the flow ID and sequence number or not. Okay, so that's how we know what the length of the option is. Greg?
Yes, sorry to interrupt you, but I think that it's convenient that we have this slide. So I understand that you implicitly define by the length what's option included or not. But I think that there are possible situation when, or at least, is it possible that only flow ID or sequence number included? Because then it will might create an ambiguous situation to understand what this field is.
The way it's currently defined, it's either you have both of them or you have none of them, because we wanted to limit the number of possible combinations and to make it simpler. So we only have two flavors. One is without these two fields and the other is with these two
I see.
fields.
Okay, thank you.
Okay, so this is the format over an IPv6 extension header. So basically this draft is based on the inputs we received from the working group. It's a combined solution, and we believe it addresses what we heard from the working group. And we believe currently the draft is pretty stable. So we would like to consider working group adoption and would be happy to hear any comments.
Greg Mirsky, ZT again. I have a question, and probably it will be interesting to discuss as part after my presentation. But this proposal is for any network or only for unicast networks?
Do you see there's a difference between?
Yes, I see the difference, and I'll bring in this for discussion in my presentation of implication on IOAM and other telemetry collection methods in multicast networks. Yes.
Okay, so that's a point to think about.
Yeah, I'm from Huawei. In my opinion, right now this work is only considered for the unicast, and for the multicast we need more extensions. Thank you.
Okay, any other comments or questions?
Well, I think one more thing, what we might want to go, this is Frank Bruckners. One more thing is we want to go and adopt the nomenclature that we have in the data draft now. So it's DEX option type. Right, so I think getting those two in lockstep.
So I would say that, like, so that would be a comment for the 00 rev, like, so, you know, so the feedback here, you know, if we choose to adopt, we'd say, you know, take this feedback and put it into the 00 rev of the doc, the draft IETF IPVM 00 rev of the doc.
Barak Gosni, I do agree with the comment on the multicast, and I think we have to have this discussion in this draft because sometimes you get multicast behavior unintentionally. So, for example, flooding in the switch in the middle. So I don't think we can prevent this discussion, and we have to have it as part of this draft.
I have a question. So, as an individual, go back to the architecture diagram. This one. So this looks like a different kind of reflection and amplification attack than the loopback. So I would say that when we bring this into working group change control, we should probably ensure that the, you know, whatever we come up with to protect flags can also protect this, right? Like, so we don't want two different sort of like amplification protection strategies for the two different strategies in IOM to the extent that that's possible, because these look like differently sized cannons pointed in different directions, but they're both cannons. And if there's an approach that we can come up with that will protect us in all cases, that's worth working on.
Right. So you're saying the analysis should be done for both, even though the solution is not necessarily the same.
Yeah, and if it comes out that like these are different enough that we need two completely different ways, but like, so I'm thinking of something that basically involves like a little bit of cryptographic protection, that if you don't actually pass if like this is ripping through the network and the transit node doesn't see the token, where the token can be something pretty lightweight, then it basically just says, no, I'm not gonna point this cannon over there. And I think that like a token-based approach could work for both of these. But I think we need to do a little bit, as a working group, we need to do a little bit of looking around and seeing other places that, usually in the transport layer, so like SYN cookies are an example of this sort of thing, right? Like, so looking at the approaches that have been used like in higher layers to do this, and see if we can make them lightweight enough to work in these environments.
Okay.
Because I think that, so one thing that I know is the same between direct export and loopback is you need to apply the security at a low enough layer that it needs to be pretty lightweight, right? Like, so the constraints are the same in both environments. And that's going to constrain the space of solutions such that I suspect that even the solution is going to be unified. Suspect. I haven't done the work yet.
Okay.
Greg Mirsky, I think that this comment brings another point for discussion is whether loopback and direct exporting are, or whether direct exporting is a more general case of loopback, and whether we really need the loopback, or we can get by with the direct exporting and providing special encoding for loopback scenario. Because as I understand encapsulation, so there is no identity of their destination for the IOM data to be exported in the data packet. So probably you envision that is a part of their management data plane to set it. So something that we can discuss, how to extend DEX encoding so it can be acted as a loopback function.
Yeah, I think in my opinion, there's a distinction here between the data plane and the management plane. I think the loopback is intended to be used by the data plane,
But
whereas
why
DEX,
okay, I'm just just speculating. Why not to have a flag in the DEX saying, oh, by the way, this is a loopback? Okay, and then you don't need a loopback flag at all. Okay, but we'll talk about it later.
So I'm going to make an observation as the chair. We're already kind of having this discussion within the working group. So this is de facto a working group document now. So we should go ahead and do the call for adoption. We'll kick that off.
Okay.
Pascal Thubert, do you envisage that at some point you may have a need for a filter indicating what kind of data needs to be exported? Or do you think that implicitly you always know what needs to be exported?
Yeah, so the assumption here is that the encapsulating node doesn't insert a DEX option into all the packets. It does that based on some kind of filter, which can be either a statistical.
But say I have 5 types of data in my node that I may report. And sometimes this may be important, and the other time this may be important. And maybe you want to say, hey, you guys along this path report this particular information. Yeah. And I see that you don't seem to have any filter of any sort to be able to indicate that sort of thing.
What you mean is that the encapsulating node, you're looking for something for the encapsulating node to indicate what kind of traffic this is?
No, can we go to the next slide? Yes, so the flags is encoding of what type of information to be exported. It's a part of standard IOM. Yes. Yes. Yes.
Okay, but if I collect 5 things and I want to export 1 at this point, how do I do that?
So we got 1 more minute for this draft.
One real quick clarification. So that the trace, this is Frank, the trace type tells you what is collected, right? So the encapsulation node will put into the packet what is going to be collected. So the assumption is that you only collect what you want to go and see exported. It's not the way that you say, okay, that you have the encapsulator. It's going to go decide what is going to be collected, and then the exporter will just export everything that is collected, right?
Okay. No.
As opposed to, so you have the encapsulating node decide on what should ultimately be exported, as opposed to,
Feature to the other one.
correct, as opposed to the exporting node will decide on that.
Yeah, so you can't decide for particular export, just this piece or that piece. You can,
Well, I think otherwise, like if the exporting node would go and decide what to export, right? Then you can do that today. You don't need anything IOM for that. You don't need anything signaling for that. So the whole point of IOM is that the encapsulating node can signal to the intermediate node, this is what you should go and grab and send off. Otherwise, I can go and implement like something like, otherwise
Yeah,
it's just
okay,
a better tracer or whatever, or
This is a good discussion. I think going into this on the list to discuss offline would be great. So I think this is a very interesting topic, and thank you again for doing all this collaboration. We really
Thank you.
appreciate it.
Tal, one quick question. Just give me a thumbs up or thumbs down on this. After adoption, there's no need for the continuing collaboration infrastructure for this document as a design team. We can go ahead and close the design team meetings, or?
I think, in my opinion, it's useful to have a list, a mailing list.
Okay,
and
the
also-
mailing list is still up. Yeah.
Yeah, and also probably bi-weekly meetings. Maybe
You want to keep them running?
idea.
Okay, it's like, so keeping them running is a no-op for me. I'll just let them stay.
Yeah, I think it would be a good idea. We may want to change the scope of the list and the meetings, but I think it's important for us to keep it going.
Okay, good. Let's take the scope change offline.
Thanks.
Thanks.
So that I get to the end. Hi, I'm Al Morton, and Len Chavatone and Rudiger Geib, who have been active members of the group here, have been working on a draft with me called Metrics and Methods for IP Capacity. This is a draft where we're defining a metric for something that we can really hang our hats on, this maximum. It's kind of like a physical capacity. We should be able to measure this, and it's been kind of a holy grail of this group to measure capacity of links and so forth. It's becoming extremely important in the part of the world where we're offering a gigabit access to every user who can spend, I don't know, $300 a month. So it's an important thing. Now, it's at the IP layer. That's where we've defined it with header plus payload. And we have a word definition and this equation definition in the draft. Also a method of measurement. So we've got these time intervals. They are typically 1 second. We're generally using 10-second measurements. And we've tried to find the maximum interval. That's going to be the maximum capacity. And we also have a search algorithm in the method of measurement. And so a typical search kind of looks like this, where it converges, maybe overshoots a little bit at first, but it converges on one of these intervals where we can identify the maximum capacity. And we've also got this side measurements of loss, delay variation, and so forth. These are the kinds of things you can't get with TCP, but TCP is being used everywhere, and TCP falls short when you're trying to measure gigabit access, even half a gigabit access. There's always going to be some error there, and that's the problem with the current methods of measurement. Now, UDP is coming, QUIC is coming. This is the simplified way to measure IP layer capacity. So we've had an enormous amount of discussion on the list, and I'm not going to go through all of this with you. In fact, sitting in the back there, I realized that this isn't even readable from the back, so let me just pick up some points. Bimodal features are still being offered in internet access, where you get a turbo boost in the first couple of seconds and then it drops back down. We've got that covered now in the methods of measurement. Also, IP layer capacity is different from goodput or throughput, so let's not mix those together. It's a different metric. Okay. And by the way, in the slides, which I hope you all take a look at, the action points are in the at, and then the +++ is what we did in the draft to deal with it. So we've got about 15 of those just in the September list points. So feedback from Joachim Fabini, who's here. Welcome back, Joachim. He said, formulate this as a statistic based on the singleton. That's the way we've always done metrics here before, so we've got that done now. And we've also got a qualification measurement that we talk about in the considerations, methods of measurement, and we're proposing that at a fixed 99% of whatever we come up with in the search algorithm. So that's something we can talk about. And of course, we've got the, with the 0-0 draft, we spelled capacity right. That's at the bottom line. So then the October list discussion between mostly 3 of us and also a meeting where we had 5 or 6 of us together in Darmstadt. Basically, we were looking at averaging times. The ones that we chose seemed to work very well, of 1 second and 10 seconds for the whole test. Matt Mathis was proposing something a little lower. We did some tests with 50 milliseconds and didn't seem to improve things, actually. So one of the things we did this time, we haven't done this in previous drafts, was to go with default values for the input parameters to the metric. And that's what the defaults are, the 1 second for the measurement, short measurement intervals, the time for the singletons, and so forth. So that's new. And let's see, the consideration for testing parallel flows, we've added that, and the sending rate measurements. We've also added defaults and some additional information there. So all of that went into the draft 01, which is now the 3rd version. So next steps. It's good to recognize that there is still an active methods and measurement community in the working group among all the protocol developers that are here. And I'm sure you guys are all interested in a little of both. So let's continue this. Oh, that's good. All right. That means I've got 5 minutes left. And that gives us a little time for discussion, so that's cool. So the authors believe it's worthy of working group adoption. The key points there are harmonization. There's parallel efforts going on, which we tried to coordinate with liaisons, but the best way to do this, we've found, is to get the spec going someplace. And that way we get the feedback of review of the metric and the methods from the community. We get their unique perspectives, and we get to the point where they can do the things that they want to do. The unique thing we can do in IPPM, after we've got the metric to point to and our unique perspectives, is to help this out with the protocol enhancements in whatever protocols we choose, like TWAMP, like STAMP, all of those. So I think that's the kind of second step beyond adopting this and reaching consensus. Then we can work the protocol aspects. So the point is to reach consensus fast and then start that protocol support. I would suspect that we could, because we've got so much experience with measurements, a year and a half of measurements, and this is being worked in other standards bodies as well, that we could probably get this done by May and then start the protocol stuff. So, but that assumes that we go for working group adoption sometime in early 2020. If we do that. So I'd like to open up the microphone for comments and let's I guess let me ask the question: who here in the room has read the draft? And there's 2 people. Ignacio has read it on the Jabber, and there are obviously there are 3 authors and so forth out there. Dave, that was a time for you to raise your hand too. Okay, comments.
Mike Ackerman. Al, thank you. This is really good work. I'm excited to see this in action. How do we move it along, and how can I assist if in any way?
Review it on the list. That would be the best way.
Okay, I see a lot of potential good uses in corporate networks and others.
Cool, thank you.
Nalini Elkins. I support this document too, because that's certainly a question that I get asked a lot, is what is the capacity of this link that somebody, ISPX has just sold to me? And we're going to be getting higher and higher bandwidth all the time at more and more expense. And the other thing I really like is the harmonization part, because I'm sure we can all point to several different groups where there is a heated battle between different standard organizations. And I really commend you for doing harmonization. So I support this.
Flesh and blood liaison.
That was almost a tee up for my comment. So Dave Senecrope, I'm using the IETF Liaison Manager of the Broadband Forum hat. This work is of interest to that community. They've actually taken note of the draft, and there's some ongoing work that would utilize the draft and look at its application within that community. So I'm not speaking on behalf of the forum, but I do know that there's interest from that community in having this draft progress. Thank you.
Yeah, I think we're just going to go ahead and start a call for adoption now.
Cool.
Like we're running the working group last calls like in a pipeline, but call for adoptions. This seems separate enough that I think everybody's already made up their mind, so we don't actually have to pipeline it. So we'll start one. I'll just basically copy and paste the last message I just sent to the list and change the draft names. And then that'll end on the 9th of December as well.
Cool. Thank you. Thank you, everybody. Please read it and enjoy it. It should be fun.
Thank you, Al. That's great work.
That's good work.
Thank you.
All right. And Greg?
Yes.
Close us out.
10 minutes, perfect. Okay.
Okay. Yes, of course. I should know. Okay. So as I mentioned in the comment earlier, we want to bring up for the discussion and consideration is the specific aspects of telemetry collection on path in multicast networks. If we can go next slide. Doesn't. Oh, okay. Okay. No. Okay. Monitoring multicast traffic is as important as monitoring unicast. So that's important. It helps to reconstruct, visualize the multicast tree and performance monitoring and troubleshooting. So on-path telemetry collection technique is promising as a complement to the active OEM measurements method. So what's the problem? What we see is a problem. The currently on-path telemetry techniques may have an issues that when we are when per hop collection is used, that means that the same data collected upstream will be replicated on all branches and carried on all branches, which will lead to unnecessary data being collected. Because if you can imagine from the upstream, so you're doing a replication in any nodes, that branch nodes downstream. So all the information collected upstream will be replicated on each and every branch. Okay, if you agree with this mental picture, then what's our objective? To provide the mechanisms that allow optimization of telemetry on-path collection in the multicast network to avoid unnecessary replication of data. Okay, next slide, please. So for the per hop solution, so their postcard or DEX proposal, the branch node replicates the packet. And branch node needs to add the branch identifier so that their collector of the telemetry can do association and reconstruct their multicast tree. So it doesn't really change their method. The only thing, it introduces additional informational object that needs to maybe consider it to be included in encapsulation. And again, yes, I haven't synchronized that with the latest DEX proposal.
Just a question. Can you please explain what you try to optimize? Do you try to optimize the capacity on the disks that will hold this telemetry, or the network?
Okay. There are several methods of collecting telemetry information. what we're trying to optimize, okay, what's this points to is that if data is collected in the packet itself, then as packet get replicated down the branches, it leads to unnecessary information being collected in the network or carried in the network.
You mean that you could have dropped the initial?
I can hear you.
Do you mean that you might have been able to drop the initial data that's collected instead of replicated?
No, I'm not saying what to do. I'm saying that there is a problem. If you agree with this problem, then
I'm not sure if I understand the problem. So
okay, the problem is if you collect telemetry information in the packet itself, and as you replicate the packet, so the information then being collected upstream to the branch will be copied in all replicated packets. Okay? Would you agree with that? That's a problem.
So again, I agree that you replicate. I'm not sure it's a problem, but that's fine.
Okay.
Thanks.
Okay, so this is for a very special method of doing telemetry collection using either postcard. Basically, it's a per hop solution. It can be said this is a DEX solution or postcard telemetry. So which each node exports the data. And the observation of the authors of the draft was that the current information then being proposed is not sufficient to do the association. So their proposal is just, we're not changing their method of collecting information from each hop, but we are just adding additional information that helps to correlate collected data from the transit nodes as belong to the same flow through the multicast distribution tree. Yes.
Frank Brockness, one quick question here. Have you considered, so we don't really specify the semantics of the node ID today in IOM data, in the data draft, right? So what you can go and do is you can encode the node ID plus your branch ID in the node ID field. Right, so I don't believe that you need an extra field for that.
Okay, again, we can discuss whether there is already sufficient or not. This proposal was, I believe, that from the same authors that are part of the design team for the DEX. So they looked at their earlier proposal with their postcard, and they suggested that whether there is already informational element that can be included into their exported data.
Yeah, this is how you from FutureWay. So currently, we haven't defined how you will actually implement this labor branch, but you can use any existing mechanism in the DEX or whatever you can use. But here we just point out what extra information you will need to identify the branch, help you reconstruct the entire multicast tree.
Okay. Okay, next slide, please. Okay, so another method is that collecting information is a per segment solution based on a hybrid two-step. So the hybrid two-step is not collecting data in the packet itself, but rather constructs their similarly encapsulated special packet that collects data following their packet that is a trigger, which is similar with the postcard and DEX. The only difference is that postcard and DEX operate on per hop, and this collects from end to end all the information. So you can see that without any modification, hybrid two-step will lead to the replication of unnecessary replication of collected data, because their HTC packet that collects data uses the same encapsulation, so it will be replicated as a data packet, and thus will lead to the unnecessary multiplicity of information. So instead, to do optimization is that basically it's very simple, saying that the first packet is being transported with all information, and if packet needs to be replicated, so if this transit node happens to be a branch, that node generates a new HTTP packet. As a result, you can see here, so that only information on this branch will be collected. Then you will have only one end-to-end on one branch, and everything else is per branch from the branch node to the leaf. And that's basically all of that. In Postcard may have enhancement for optimization. Yes. Oh, sorry. Okay. So it has optimization. We ask for your consideration, comments on the list, and discussion, and down the road somewhere, adoption. Thank you.
Thank you for bringing that. All right, so if you haven't signed the blue sheets, they're over here. And other than that, we have a lot of new stuff out for adoption and for last call. So please respond to those on the list. And thank you so much for your time. We'll see you in Vancouver.
I just sent you an invitation for the 9th of December, when like our next, when everything ends and restarts. Like I think it's 8 a.m. your time, if that works. 8 a.m. on Monday is doable. Yeah. All right. Is it 30?